This conference will now be recorded.
Okay guys, let us start today's session. So in our last session, we have learned about the concept of AVL tree. So before learning AVL tree, what we have learned is that what is the limitation of binary search tree. We have seen that in the worst case, at the time of insertion in binary search tree, it may lead to a tree which is called right skewed tree, or it can be left skewed tree. And in that case, sir, order of insertion may take the time as order of n, because n number of comparisons are required. But if we go for AVL tree, which we have not learned yet, if we go for AVL tree, we have found that, sir, we can reduce the number of comparison to order of log n, where log n is very less number compared to n. If the value of n is large, na guys, too large, then the log n value will be much more reduced. You can think 8, n is 8, log n will be 3. Just for n 8, it's 3, 5 gap is 5. So the more n will be increased, the gap will become more. So that means log n base 2. Base 2 is very important. Sometimes they ask, what is the base? Base 2. So log n base 2 compared to n is very less, sir. But how I will construct this tree? Yeah, that is what we will learn today. Then we have seen some definition. AVL tree is given the name as per Russian mathematician Adelson, Velsky and E.M. Landis. Then we have seen what is called Hyde balance tree. Then we have even seen what is called balance factor. How to calculate balance factor? Very easy, sir. Balance factor is always the difference between height of left minus height of right. Height of left subtree minus height of right subtree. Always have to remember, if you make any mistake in this formula, HR minus HL, error will start onwards. It will be always HL minus HR, sir. Height of left subtree minus height of right subtree. And for a tree to be balanced, all the nodes must have the balance factor value either as -1, 0 or 1. I repeat, inject it in your brain. For a tree, when we will say that this tree is balanced or not, all the nodes, not only one nodes, all the nodes must have the balance factor value -1, 0 or 1. Suddenly you found that one node balance factor is other than 0, other than these three values. Other than these three values means other than -1, 0 or 1. Immediately will tell, sir, the tree is unbalanced. If the tree is unbalanced, what you need to do? Sir, I need to make the tree balanced. How you can make the tree balanced? Sir, to make the tree balanced, I need to perform rotation. What kind of rotation? 4 types of rotations are there. Today we are going to learn that rotation. But before learning rotation, another definition we have learned in the last class, that is called pivot notation. Pivot node. What is called pivot node? Sir, the node which is nearest to the newly inserted node. Newly inserted node means the node which is just now inserted. From that node, the node which is nearest to that newly inserted node, that means from that newly inserted node, the node which is closest and have lost its balance factor, that is called pivot node. And which path he will take for that? So the path will be always newly inserted node to the root node. In that path of newly inserted node to root node, if I found any node which lost its balance factor and closest to the newly inserted node, that is called pivot node. Understanding my statement, guys? Now let's see how to perform the rotations. First, let's take an example, and then we will take the point with respect to the rotation. Okay, so or before that, let me first take the points and then we will see the example. So first is ALL rotation. Listen very carefully. What is this ALL rotation? LL. Why the word LL is chosen? Why the word LL they choose? Observe here. When the pivot node is left heavy. Sir, pivot node is left heavy. Pivot node definition I understood, sir. Left heavy means what, sir? Left heavy means if height of its left subtree is one more than its right subtree, that is called a left heavy. Okay, let me, as I use this word left heavy, let me put the meaning of left heavy also, so that in future also when you will study this node, you will never face any difficulties. Sir, what do you mean by left heavy? A node is called left heavy. A node is called left heavy when if height of its left subtree is one more than height of its right subtree. That is called left heavy. That is called a left heavy. Simple, sir. Height of its left subtree is one more than height of its right subtree. That is called left heavy. So if a node is left heavy and new node is inserted in left subtree, new node is inserted in left subtree, new node is inserted in left subtree of left child of pivot node, then the rotation is performed left to left. Then the rotation to be performed is left to left. LL rotation, guys. LL rotation. Now, if you observe carefully here, how many times the left word came? Here once left, here once left. That's why LL rotation. But first one is subtree, sir. Next one is child. And this is another very important word that is called pivot node. So when the pivot node is left heavy, what is called left heavy? A node is called left heavy if its height of its left subtree is one more than height of its right subtree. So can I put the definition some here? Okay, let it be here, no problem, you can understand. Because just for addition of this part, now this point is getting a bit bigger. No need to worry, you can understand that. So this part is the definition of left heavy, and that's very simple. Height of left subtree is one more than height of right subtree. What is there? But when the pivot is left heavy and the new node is inserted in the left subtree of left child of pivot node, then the rotation is performed. Rotation to be performed is LL rotation. Rotation to be performed is LL rotation. Let's see, can we put an example where this is RL. Okay, this much space is enough. Okay, let's take an example here. Let's take an example here. Let us take some numbers and construct an AVL tree. From them, what are the numbers? 50 guys, 40, 35, 58, 48, 42, 60, 30, 33 and 25. Let's start. You remember insertion in AVL tree, the very first point is, sir, the insertion is same as binary search tree insertion. Remember the first point, guys? Insert the node at the proper place following the same process of binary search tree. Already we know binary search tree insertion, sir. Then how you will start? Sir, it is very simple. Step number one. Step number one. Sir, insert 50, sir. What to do? Very simple, sir. This is the first node, sir. I made the insertion. Simple, na guys? In the tree currently, how many nodes you are having? Only one. Is the tree is balanced, students? Is my tree is balanced? What do you say, guys? Respond in the chat box. Is my tree is balanced? Yes. Why? Because, sir, currently in your tree, you are having only one node and the balance factor of that node is 0 only. Because height of left sub is 0, height of right sub is 0, 0 minus 0 is 0, so the balance factor is 0. So the tree is balanced. Super. Sir, step number 2. Be ready to give the answer, okay? Step number 2. Sir, insert 40. Remember, guys, sir said that binary search tree type of insertion. Same process of binary search tree insertion. Tell me, students. So in step 2, when I will come, I will insert that 40 to the left of 50 or to the right of 50. Where should I go? Binary search tree insertion, na? Left. Super. Let me insert that. 40 got inserted, sir. 3 means vertices will be there, edges will be there. Great. Is your tree is balanced? Listen first. Don't say yes or no. First listen. Is your tree is balanced? Whenever I ask, you have to calculate the balance factor. But the question is, sir, from where I will start calculating the balance factor? Always remember, balance factor calculation will start from newly inserted node to the root node. And if I found anyone lost it, I will stop. I will not calculate for the other fellows. It's not like you will start calculating from root. No. Balance factor calculation will start from where? Newly inserted node to root node. And if any node lost it, I will stop. One more time. Balance factor calculation will start from newly inserted node to root node. And if any node lost, I will stop. So from where you will start calculation here? Sir, 40. Tell me, guys, what is the balance factor of 40? Firstly, you have to give the answer. 0. Super. What is the balance factor of 50? 1. Height of left subtree minus height of right subtree, na sir? Height of left subtree is 1. Height of right subtree is 0. So 1 minus 0 is 1. At any stage, if you fail to understand, immediately, ping me in the chat box. Sir, I didn't get it. Repeat. Okay. So the tree is balanced, guys. Currently is the tree is balanced? What do you say? Yes. Then don't do anything, sir. Move on. Step number 3. I need this set of numbers. So let me take a copy of this. Basically, these fellows I require. Step number 3, sir. Insert 35. Basically, I need this fellow also. $35. Sir, very simple, sir. Binary search tree insertion now. Let me copy this tree. 35. Oh, very simple, sir. Where it will be inserted? Sir, to the left of 40. Where it will be inserted, guys? To the left of 40. $35. As soon as you insert, what is your next job? Sir, calculate balance factor. Previous balance factor I'm deleting. From where you will calculate the balance factor? Sir, from newly inserted node to root node. Guide me, guys. Balance factor of 35. 0. Super. Balance factor of 40. 1. Super. Balance factor of 50. 2. Tell me, guys, tree is balanced? Tree is balanced? No. Immediately. For the first time, sir. For the first time. It says, na, if the tree is not balanced, if the tree become unbalanced, now it become unbalanced. After the insertion of new node, then there is a need to balance the tree by performing rotation. Rotation will be done with respect to what, guys? About the pivot node. Sir, what is pivot node? The node which is nearest to the newly inserted node and absolute value of balance factor greater than 1 is marked as pivot node. Tell me, guys, here who is your pivot? Who is your pivot here? 50. Very, very good. Sir, 50 is my pivot. I identified here two things, sir. Two things I need to identify here. First of all, who is pivot? And rotation will be taken place with respect to what? First thing I identified, pivot. That is 50. Pivot is 50. Super. Rotation need to identify. Till now, one rotation I have learned. Let's see it is satisfying that or not. When the pivot is left heavy means height of left subtree is 1 more than height of right subtree. So definitely, sir, height of left subtree is what? 2. Is not only more than 1 but more than 2, sir, because right subtree height is 0. Thing is that if the height of left subtree is more than the height of right subtree, of course, definitely by more than 1. More than 1 means it can be any value. Can be 2, 3, can be anything. A node is called left heavy or right heavy if height of its left subtree is, better to say, not 1 more than, because 1 more than may be a little bit confusing, is more than the height of right subtree. That will be more meaningful. Is more than the height of its right subtree. And the new node is inserted in see, can we relate this in that rotation to identify there or not these words? When the pivot node is left heavy, is pivot is left heavy, guys? So left heavy means if height of left subtree is more than the height of right subtree. Yeah, height of left subtree is more than right subtree. So left heavy. And new node is inserted. Where a new node is inserted? Here. In left subtree of left child of pivot node. Who is pivot node? This is pivot node. Pivot nodes come from here to here. Pivot nodes, left child, left subtree. Where insertion take place? Tell me the answer with respect to pivot node. Pivot node, left child is this. Its left subtree can be a big one, sir. Currently only one node, but as the tree will grow, it can be a big one. But left child, right child, they will always be one node. But left subtree, right subtree can have can have many number of nodes. Currently in the left subtree, one nodes doesn't mean always left subtree will have one nodes. As the tree will grow, then definitely I have more nodes. So come from here. Is the insertion is taken place in pivot nodes left child left subtree? Sir, this is pivot node. Its left child's left subtree. Is the insertion is taken place in that place? Yes. Then the rotation is performed as left to left, LL rotation. LL rotation is, let me write here, LL rotation is anti-clockwise rotation. LL rotation is anti-clockwise rotation. And how the rotation will be performed, sir? Observe here. Always rotation with respect to pivot node. Always the rotation will be performed with respect to pivot node. Anti-clockwise, na guys? Anti-clockwise. So bend it like that. Bend it with respect to pivot. Rotation is LL, sir. Tell me, guys, who will be the root now? If I bend the tree from there, who will be the root now? Sir, 40 will be the root. Any doubt, students? If I bend the tree like that, who will be the root, sir? 40 will be the root. Tell me, students. Who will be the root, sir? Bend it like that. Put your hand and bend it like that. Sir, who will be the root? 40 will be the root, sir. 40 will be the root. If 40 is the root, who will go to the right of 40? If 40 becomes root, who will be coming to the, oh sorry, this is clockwise rotation. No, I made a mistake here. This is clockwise, this is not anti-clockwise, sir. This is clockwise, correct. This is not anti-clockwise, this is clockwise. This is clockwise, correct. Clockwise rotation, sir. LL rotation is a clockwise rotation. So then now who will be the root? 40 will be the root. Who will be the right of? Acha, confused about pivot node. I will come back. Let me first complete this tree. Then who is current root, sir? 40. 40. Who is right of 40? I bend it from there. So that means it will be 50. Who is the left of 40? 35. Listen, Aniket. What is called pivot node, sir? From the newly inserted node. Who is the newly inserted node here? 35. Go towards the root node. Going. While going, check the balance factor of every node. Oi, what is your balance factor? 0. You are safe. Going. Oi, what is your balance factor? 1. Okay, you are safe. What is your balance factor? 2. Oh, sir, I found one node who lost its balance factor. This is your pivot node. So what is the definition of pivot node, sir? From the newly inserted node in the path of newly inserted node towards the root node, the node which lost its balance factor and closest to the newly inserted node is called pivot node. Why closest? Because multiple nodes can be there who lost its pivot, who lost its balance factor. Everyone will be considered as pivot, sir. No. The one which is nearest to the newly inserted node. If it happens multiple node lost its balance factor, that means I have to pick up the one which is nearest. Or rather, better to say, once I get it, I will stop. I will not conclude. I will not calculate the remaining ones. I got the pivot now. That's why no question of getting more than one node having lost its balance factor. If I found any node lost its balance factor, I will stop there. And that will become my pivot. Aniket, super. LL rotation understood perfectly. Any doubt about LL rotation? When to go for LL rotation? Very simple, sir. After identification of pivot, na sir, I will check where insertion take place. Pivots always with respect to pivot. Sir, if I ask where insertion take place, sir, pivots start from say pivot. Pivots left child's left subtree. How many times left came? 2 times. So LL rotation. LL rotation. Can I move to the next one, guys? Sir, if I understand LL rotation, sir, RR rotation will be exact copy paste of this fellow, sir. RR rotation will be exactly copy paste of this, sir. Only thing is that, sir, all left will be replaced by the word RR, right. Let us start changing this. This will be number 2. What is that, sir? RR rotation. So which thing basically I will remove from here? This fellow will be removed. This left will be removed. Left will be removed. Left, remove. Left, remove. Left, remove. Left, remove. Then, sir, this is RR rotation. Pivot node is right heavy. A node is called right heavy. If height of its another fellow is there, na? right subtree is more than height of its left subtree. And new node is inserted in the, I need that right word, anywhere else? No. This is RR rotation, sir. RR rotation. RR rotation is what? Anti-clockwise. Is anti-clockwise. So that means, sir, difference between LL rotation and RR rotation means LL rotation's exact reverse rotation is RR rotation. Mirror rotation, sir. LL rotation, mirror rotation is what? RR rotation. Nothing difficult here. If I understand LL rotation, I will automatically understand RR rotation. Very simple. Okay. So next, where we will concentrate is LR rotation. That's very important. Sir, when should we go for LR rotation? Observe, listen. LR rotation. When the pivot node is left heavy, or let me do one thing. You may feel a bit difficulties with this definition. Let me remove this part. Left heavy part, completely remove this. I'm deleting this, sir. It will become simple. When the new node is inserted in left subtree of left child of pivot node, in left subtree of left child of pivot node, then the rotation is performed left to left, and it is a clockwise rotation. Now it's becoming very simple, guys. Same way, sir. When the new node is inserted, in is 2 times now, in right subtree of right child of pivot node, comma, not full stop, comma, comma. Then the rotation is performed right to right. Much more simple now, guys. Here it's not capital T, small t. I'm not feeling the pressure of that definition. Yeah. Next, sir, AVL rotation. So when the pivot node is not anymore left heavy. You don't want to take that left heavy, right heavy, forget about it. So when the new node is inserted, listen, when the new node is inserted in right subtree of, now it will be a combination. When the new node is inserted, right subtree of left child of pivot node. See guys, which what came? Right, left. But I have to take in which direction? From here. Pivot's left child right subtree, not from here to here. Pivot's left child right subtree. That's why the rotation is LR. Pivot's left child's right subtree. So when the new node is inserted in right subtree of left child of pivot node, then the rotation is performed left to right. Then the rotation is performed left to right. This is a bit dangerous one. Why? Because listen now, LR rotation is a double rotation. Double rotation means what, guys? Oh, 2 times I have to perform rotation now when I identify the LR rotation. Yes, sir. LR rotation is a double rotation. What is that double rotation? Number one, first one. First, we need to perform. First, we will perform which rotation, sir? Right to right. Oh, that means under LR again RR will come, sir. Yes. So first we will perform RR. So LR means first RR. First we will perform RR. Around, not pivot, around node A. Who is node A, sir? Who is that node A, sir? Around node A. Yeah, that is what I have to tell here, na? Where A is around node A. What is that A, sir? Because previously ALL rotation, RR rotation you said with respect to pivot, but suddenly you are telling here RR rotation have to be performed around node A. Who is that node A? Where node A is left child of pivot node. Don't get confused, guys. We will have a practice. We will make sure we will do it perfectly. No need to worry. Where node A is the left child of pivot node. That is the first one. LR rotation you said na two part is there. Sir, what is part B? Double rotation first part is done. Secondly, this is first, second. Perform left to left. OLL. Yes. Perform left to left. Super. Always whenever it is rotation, you will ask, sir, with respect to perform left to left around pivot node. Oh, that's not difficult. Second one is not difficult. It's my favorite. Around pivot node is my favorite because every time I'm doing it, na sir. So that means in one word, what we can say? LR is equal to what, guys? RR plus LL. LL will be with respect to pivot. RR will be with respect to pivots left child. Pivots left child. Sir, show with an example. Getting too much confusion. Left, right. I will give you left and right. Sir, then what will happen, sir? Let's see LR rotation. At least perform once. Can we get it or not? As per our example. Now come here. That's I'm moving very slowly. Okay. So up to this is done, sir. So what is your current tree? Sir, this is my current tree. This is my current tree. Okay. Now what you will do? Acha, in the previously current tree, guys, current tree is balanced na? This tree is balanced na, guys? Sir, balance factor of these two fellows are 0, 0, and this fellow is what, guys? This fellow is also 0. So after rotation you get the benefit na? After rotation your tree become balanced na? Yes, sir. After rotation tree become balanced. But before rotation tree was unbalanced na? Yes, unbalanced. So currently your tree is balanced? Yes, currently my tree is balanced. Remove these fellows. This time what you will insert? 35 done, sir. Next is step 4, 58. 58, sir. Step 4. Insert 58. Sir, where 58 will be inserted? Sir, BST insertion, na? This is 58, sir. Compare with root, greater, right side. Compare with this fellow, this 58, greater, sir, right side. When it will be inserted, sir? Here. 58 inserted. Insert. After insertion of 58, guys, is the tree still balanced or unbalanced? No, sir. I need to calculate the balance factor. Then I will tell you. Acha, you calculate. From where you will calculate? Every node you will calculate. No, sir. Then, sir, from newly inserted node. Who is newly inserted node? 58. Sir, I will start from here. Tell me, guys, balance factor of 58? 0. Next, balance factor of 50. Aniket, height of left subtree minus height of right subtree. Height of left subtree minus height of right subtree. -1, sir. Acha. Height of this node, this is this balance factor. Still -1. Correct. 35 balance factor. 35 0. Sir, 35 is needed, sir. No, not needed. Not needed, sir. Newly inserted node to root node. Why should I calculate 35, sir? Unnecessarily wastage of time. No, not needed. Just newly inserted node to root node. Tell me, is the tree is balanced or not balanced? Tree is balanced or not balanced? Balanced. No need to do anything. Happily, we can move to the next step, sir. Let's move with this tree also, because this is my final tree. Current tree, not final tree, current tree. Okay, sir. Step 5. Insert 48. Insert 48. Sir, where? This is your 48 with root greater. Okay. With this lesser. Where I will insert? To the left of 50. To the left of 50. Insert. Insert. So first let me remove all my previous calculation of balance factor. I have to recalculate. Okay. So this is which one you inserted? 48. Calculate the balance factor. Every node, sir. No. Newly inserted node to the root node. Oh, sir, first 48. Tell me, guys. 0. 50. Tell me. 0. Next. 40. -1. Good. -1. Remaining need to be calculated. No need to calculate, sir. If you want, you can calculate. Today only 1, 2 node you can calculate. If it is more node, then not needed. Tree is balanced now, guys. Tree is balanced. Do I need to perform anything, sir? No, I don't need to perform anything. Let us move. Step number 6, sir. Insert 42. Easy, sir. This is my 42. Greater than this? Yes. Come here. Less than this, sir. Come here. Less than this, sir. Insert here. BST insertion process, na sir. Already done. So very easily inserting, sir. Inserting is not issue. Issue is identifying pivot and then identifying rotation. This time you will help me to identify the rotation. Where I'm writing. 42. Let's calculate pivot. Tell me. Balance factor of 42. 0. 48. 1. 50. 1. Super. 40. Very good. -2, sir. How? Sir, height of left subtree 1. Height of right subtree, sir, this one or this one? Maximum path to reach to the leaf node. Sir, this path or this path? Maximum path. Maximum path length reaching to the leaf node. This is the maximum path length reaching to leaf node, or this is the maximum path length reaching to the leaf node? Sir, this one. Then what is the height of right subtree? Sir, 1, 2, 3. Then 1 minus 3. -2. Got it? Got it? How it is -2, sir? Yes. Now, the problem that I'm going to face, sir, I have to identify rotation, sir. I have to identify the rotation, sir. Okay. So till now, what you identified? Pivot. Tell me who is the pivot here, guys? 40. Pivot is 40. Now identify where the insertion take place. New insertion take place where? Achha, before that, let me write here pivot 40, sir. Pivot 40. Achha, where the new insertion take place? Come from pivot. First, either left child or right child. Pivot's left child or right child. For newly inserted node to get there, to reach to the newly inserted node, first movement will be what? Always think about first movement. Pivot's left or right? That's correct answer. But first movement is what? First movement is what? Right. So that means pivot's right. That means pivot's right child. Right child's where? Left subtree, na? Where the movement, where the insertion take place? Pivot's right child's left subtree. Understanding or not? This part is left subtree, na? This part is left subtree, na? This is right child. This is left subtree. Arey, who's left subtree? Pivot's left subtree. No, sir. Right child is left subtree. Then what is the terminology? I'm asking where the insertion take place. Sir, pivots. First movement, think about that. Left or right? Right. Sir, pivots. Right child's left subtree. Then what will be the rotation, guys? What will be the rotation? Tell me. RL. Pivots right child's left subtree. Sir, the rotation is RL rotation. This is RL rotation. Super. We have taken the point with respect to what? LR. Oh, RL will be mirror image, na sir? RL will be a mirror image of this definition. RL will be a mirror image, sir. So that means what? Sir, this fellow will not be there. Then who will be there? Sir, it will be RR. Okay. Is equal to. What will be there? Tell me, guys. By seeing that formula, RR is equal to. RR is equal to. Sorry. RL is equal to. RL is equal to. LR is equal to RR plus. So RL is equal to. When I write LR, then RR is equal to. Then RL is equal to. Observe here. When I have LR is equal to RR first. So RL is equal to. LL. With respect to pivots. Earlier it was left child. Then this time right child. Right child. Done. Sir, plus earlier it was LL, then sir RR with respect to pivot. With respect to pivot. So I just change this part. There are so many parts I need to change. Right? Just till now I change this part because we are not having that much time left today. So tomorrow I will change the remaining part. Sir, this will change. So many places it will change. Currently focus about this one. So that at least we can do the operation. Tomorrow I will make the changing here. I'm not touching this one. Just I need this one. By that I can able to do the operation. That's I'm making the changing here. Tomorrow I will make the changes here. Okay. Come here. You are supposed to perform which one? 42 insertion is done. Let me remove it from here. Tomorrow we will insert the remainings. Currently where I will focus? Sir, this rotation I have to perform. Do it. So this fellow, guys, RL is a double rotation, na? Let us assume this part I'm considering as RL first part. That means RL1. And this part I'm considering. This part I'm considering RL2. Second part of RL. Second part of RL. Let's first perform the RL rotation. RL1 first. So if we perform RL1 first, let me write here RL1. Simple, sir. Pivot's right child. Who is pivot's right child, students? Who is the right child of pivot? 50. With respect to that, which rotation? LL rotation. So LL rotation means, sir, LL rotation is a clockwise rotation. LL rotation is a clockwise rotation. LL rotation is a clockwise rotation. See, students, this portion of the tree will be as it is, no change. So what I'm doing here, I'm just copying this tree. Okay, now I will make the changes. Tell me, if I rotate it like this, who will take the place of 50? 48. Who will take the place of 58? 50. Where 58 will go, sir? 48 comes here. See guys, if 48 comes here means what? Sir, its children will also grow one step upwards, na? So 48 takes place of 50, then automatically 42 will take place of what? 48. 42 will take place of what? 48. So 42 part is done. It's not anymore there in my tree. Because if 48 grows one step upward, it will grow one step upward with its children. So that means that 50 grows one level down. As a result, 58 will go further downwards now, guys. If 50 getting down, 58 will get further downwards now. So where will be 58, sir? To the right of 50. Any doubt, students? You have completed just the first part of RL. Should your tree be balanced? No, sir. Tree should not be balanced. Why? Arey sir, I have completed only first part. Now, how the tree can be balanced? It should not be balanced. Oh, after completion of entire rotation, it will be balanced, na? Yes, sir. Really? Really, sir. You are not believing, sir. You calculate balance factor. Sir, this is 0. Sir, this is 0 minus 1 minus 1. Sir, this is 1 minus 2 minus 1. Sir, this is, acha, 1 minute, guys. How it is, 48 is coming here. 48 is coming here, na? Insertion of 42. So 40, 35, okay. 48 is coming here. This is 48, sir. This is 48. And 48 is coming. This is 42, sir. This fellow is 42. Forget to change those values. 42. Calculate the balance factor of 40. Sir, 1 here, 1, 2, 3 here. That means minus 2. Oh, tree is not balanced yet. Should not be, sir. I have not done yet. Last rotation, RR, with respect to pivot. Who is your pivot? Pivot is not going to change. Sir, 40. So the rotation will now take place with respect to pivot. RR rotation is what? Anti-clockwise. RR rotation is what? Anti-clockwise, sir. So if you make a anti-clockwise rotation, from here, tell me, students, who will be coming at the root? Who will be coming at the root? You are making anti-clockwise rotation with respect to pivot. Yes, 48 will coming at the root. Sir, if 48 is coming at the root, observe here. If 48 is coming at the root, sir, what will happen? Sir, 40 and 42 both will go one step downwards. Both will go one step downwards. I bring 48 here. 40 will go one step downwards. Here is 40. Here is 40. This is 48. This is 48. This is 40. So 48 and 40 both go one step downwards. As 48 comes here, 40 go one step downwards. As a result, 35 will also go one step downwards. Now guys, 35 will also go one step downwards. So that means this is 35. This is 35. This is 35. Both go one step downwards. Okay, sir. Next, observe here. Sir, 48 came here, 40, 35 goes downwards. So once 48 coming here, guys, don't you think that 50 and 58 will also go one step upwards? 50 and 58 will go one step upwards. Sir, that means this is 50, na? Yes. Sir, this will be 58, na? Yes. Done, sir. This is gone. Tell me, guys, there is a problem with a node. Which node? 42. Sir, 42 was left children of 48. But currently left children of 48 is what? 40. Then who is creating problem for you guys? Previously left children of 48 was 42, but due to the rotation left children of 48 becomes 40. Then who is creating problem for you? Now who is creating problem for you? Sir, earlier left children of 48 was 42. As you rotated, new left children of 48 becomes 40. That corrects. But who is creating problem among these? 48 got position, 40 got position, 35 got position, 50 got position, 58 got position. Who is not getting position yet? Who is not getting the position yet? Tell me, who is creating the problem for you? Can two nodes be simultaneously be the left children? No. So if 40 is the current left children means 48 will not be there. Then who is creating problem? 42. Always identify the node that is creating the problem for you. 42. Now where to insert? Simple. Take 42. Take 42. Insert like a BST approach. Less than this? Yes. Come here. Greater than this? Yes. Come here. Insert it here. The node which will be creating problem for you now, that node will be inserted like a BST at the end. So who is creating problem, sir? 42. Then how it will be inserted at the end? Sir, just like a BST insertion. Now you calculate the balance factor. Sir, all is entire tree is balanced. Check it out now. Do I need to calculate or you calculated already? Check that. You calculate balance factor of any nodes. Sir, leaf nodes no need to calculate. Why should I calculate? Wastage of time. This one 0 minus 1 minus 1. Sir, this one 0. This one 0. You want to write leaf nodes, you can write, no problem. You can write, no problem. But P is balanced, sir. P is definitely balanced, sir. Any issue? So up to this we completed, sir. So tomorrow when we will meet, we will go for few more insertion of these three nodes, and still we will continue with our discussion of this rotation, because today is the first day. Up to certain level you got clarity, you found that, sir, LL rotation is very easy, LR rotation is a bit very difficult, sir. No, not difficult. We will practice tomorrow one more time and we will make sure that it's not difficult, it's easy, sir. So this is the second part. This is the second part. What it is? It is RL2, sir. Pivot is fixed. Once I identify na, sir, then in that step pivot is fixed. So here pivot is, this is pivot 40. This is RL2, sir. That's it. So tomorrow we are having two jobs to do, guys. One is first correct the note of RL rotation. That note is not corrected yet. Just the last line I made it correct, because so that I can use that here. That's why that part is correct. Remaining things are not made as correct. Remaining things we have to make it correct tomorrow. The fourth one, right? And then we will continue with the remaining nodes in insertion. Hope that somewhere we will get that LR rotation also, so that we can identify the mirror image of RL rotation. So today also I'm not sharing the node, guys. Tomorrow after completion I will share the node, because it is not completed yet. Okay. Yes. So tomorrow again, if you have any doubt, you can ask me. And better if you can practice once with this data set, how far I have discussed. This is the data set, sir. Up to this 42, you can try to make insertion and check that ultimately you can get this tree or not. This is my current tree. Thank you, students.